Yes, there we go. So this idea of classes, we're going to be starting to go into, you're going to be creating your own classes and kind of working with multiple classes and bringing them together and having them integrate, correlate, kind of interact with each other. So you'll have one class call another class. You'll have a method in one class call a object in another class, so, or create an object type from another class. So that's the type of interactions we're going to be getting into in this last quarter of the course. All right, so when you define a class in Java, you're defining a new reference type. So these are those arrows in the memory stack diagram. If you were building a memory stack diagram for these objects, they would have the arrow in there. So for example, we're going to look at this die object. We've looked at a lot of dice objects, one for the midterm PA and one for another one of the labs in class, that type of thing. So this is yet another implementation of a die object. You might think I'm obsessed with dice. I really do like dice, so that wouldn't be wrong in a lot of cases. I'm a big fan of board games, role-playing games, things like that. And so I have a lot of dice around the house, and my family is big into those types of dice playing games. So I do have a love of those things as well, but it's not because of that we're doing that. Dice are really good physical objects that have a good representation and a good concept inside of programming, and they're really relatable because I think everyone has thrown a die at some point for some game. So I think everyone knows what a die object looks like, a six-sided die object at least. Your standard dice for Yahtzee, for Monopoly, for any of those games that are out there that you're rolling a dice for. Sorry, you know, those kind of games that you played, hopefully played growing up at some point, Parcheesi, those kind of things that you might have seen along the way in elementary school and throughout your life. So they're familiar things, and they're pretty simple objects too. And that's the thing, that they're pretty well defined, they're simple, and it's an easy concept to kind of translate from the physical reality of this object of a die, and then translate it into what do we have method-wise and data-wise. So data-wise, if we look at this die object, we're going to look over here at this unified modeling language diagram, this UML diagram. That's what the word of the day today was referring to, is this UML diagram here, is this face of the die. And so when we read these UML diagrams, there's a piece inside of the website here, inside of the calendar here, this UML diagram reference. This is kind of giving you the background for how to read these UML diagrams. I felt like this was important enough that I wanted to give you kind of a cheat sheet, kind of a reference page to kind of go over that. The book goes over this, but I feel like it's harder to just read that stuff than to see it on a diagram. And so this is a diagram that I built to kind of more easily represent some of these things. So you're going to have your thirds here. There's 3 thirds inside of this diagram. The top third, or the top stripe here, is the class name. Pretty simple, just the class name. The next middle section there is the attributes. That's going to be the types of the attributes that you have for the class. Then the last section, the bottom section there, the main guts of the diagram are going to be they're going to scope the method names, and then it's going to be the argument list, the argument type, and then the return type in a colon at the end there. So your scope is going to be plus for public. You'll have a plus sign for public or a minus sign for private. So this is where we're finally going to unpack that idea of a public method. Like we've been saying this mantra, public static void main, for the longest time. This public side we had not really talked about or extracted or elaborated on. That's this idea that whether it can be used within the method alone, which is private, or outside the method to be called, which is public. And that's what that means, is that we can call this method from outside the class as well as within the class. If it were private, static void main, it would only be callable inside the class, which would make it useless, because if you're calling it, you can't then call it outside the class, which you're trying to do with the main method. The main method must always be public static void main, because you want to be able to call it from outside in a Java command line. And that's why it needs to be public. So we've got that idea there, and we've got some other ideas of scope too. There's this protected, and then there's this packaged scope for where you can, the visibility of the particular attribute, or also methods can be having scope of this idea of protected or package level security, that type of thing, and availability. So these are all different types of things. We're not going to focus on the protected or the package type inside of CS149 though. The only ones we're going to deal with are the public and the private. So that'll make it pretty easy. If it's not public, it's private. And a lot of our things are going to be private just because we're trying to teach you how to create what we call safe classes and secure classes. That's very important, especially in this day and age of data security breaches and issues with people losing your passwords. Just pick up the electronic news feed of some major news site, and you're going to see probably out of the 10 headlines, you're going to see one that relates to some kind of security or internet data breach or some kind of privacy breach because somebody lost your password or somebody lost your private data. This is why this happens, is because things are not protected well inside of programs. All right, so inside of here, you're going to have these things here. You're going to have some other items here for associations between classes. So you're going to have lines with arrows, with arrowheads that are the empty arrowhead. You're going to have these dashed lines with the arrowhead, and then the dashed lines with the single arrow without the arrowhead in there. And these all mean different things. There's just an association. There's an inheritance where this class is inherited from the other class. There's a realization / implementation piece, and then there's a dependency. We're not going to worry too much about these. For the most part, we're going to be either doing an aggregation or this association. Those are the two we're going to work with the most, where we are basically either going 0 to 1 or 1 to 1, that kind of relationship there. So you've got things where we've got one class maps to one of the other class. So it's a 1-to-1 relationship or a 1-to-many relationship, that type of thing. Those are the types of relationships you can have across classes too. So over here, we're seeing this owner, and we've got one owner to many credit cards in this case. So we've got the ability to do that, where we've got this one owner can have many credit cards, is what we're saying in this instance here. So we've got this idea of a credit card class that's designed here. And you can go in here and take a look at the attributes and the methods. If you're having any questions, let me know after you review that. I definitely recommend going over this UML diagram on your own. We're not going to go over it in class necessarily. I might go over it a little more in a future class, but we're not going to cover it today, at least. All right. So we are going to look at this die object, though, in the die class. So the die class here, so the top third we're seeing is the die class. We've got this middle section, which is the attributes. We've got one attribute. It's going to be the face value. So the face value would be that top value that we're looking down on the die, and we're saying, what is that value? So it's a 1 through 6 number. So that's an integer. We're going to call that as the piece in there that is the integer value, the face value of the die. So the face is the one that is looking up onto you if you're looking at the die. So, all right. The attributes we're going to create are, we're going to need a constructor. So in order to make a new die object, we have to tell the Java program what we want to do with this object when we create it. So basically what we're going to do when we create a die is we're going to roll it. And in order to roll it, we're going to then set the face value. So that's what's going to happen in here inside this int roll. So to create a die over here, we're going to run the roll method. We're going to call the roll method here. This roll method down in the next section is going to actually take the face value, and it's going to set it for a random number between 0 and 6. And then we're going to add 1 to that. So it's going to be 0 through 5, and then we're going to add 1. So it's going to create the 1 through 6. That's how we do that. We use that math.random, which gives us a number from 0 to the number we're going to want, 0 and 1. And then by multiplying by 6, we're going to be getting a number between 0 and 5. And then we're going to add 1 to that number. And then we're going to cast that as an int because we don't want to have the leftover values. Out of this, we could have a 1.6, 1.7. That's going to round up to a 2. We're going to want to, or we're going to round down to a 1. We're going to want just the integer value of that. So that's what we're doing over there. We're casting it as an int, and we're storing it into the int face. Then we're returning that face value when we're calling that roll. So that roll gets set to the face. And what we're going to do over here is also create what we call a getter. So these items that will get us the value of this attribute, they're called getters. So this getter is going to get us and return us the face value. What you're going to find in a lot of object-oriented programming is that this programming is, as far as the code, it's really easy code. This is not difficult code to write. Obviously, you're seeing it's just 1-line, 2-line methods here. You've got 1-liners or 2-liners, and maybe 5 to 7 lines of code are, a lot of your methods are just going to be that. But it's going to be a more difficult conceptual kind of thing. So you're going to have to be able to visualize how these things interact with one another. So that's the tricky part of it all. The code is not that difficult. It's going to be, at least for simple objects, we're going to ask you to do in 149. 159 will get a lot more difficult, and it's going to ask you to do a lot more complex objects and that type of thing. But for 149, we're pretty simple in the number of objects or in the types of objects we're working with. They're going to be simple objects, and they're going to be pretty much 1 or 2 line of code where you're returning some things for getters, you're setting some things for a setter, or a mutator. So we have accessors, mutators, getters, and setters. Those are the same words. So the getters and accessors are the same thing. The setters and the mutators are the same thing, just 2 different sets of terminology. One is a little bit more high-end jargon kind of for computer science, the accessors and the mutators, obviously. And then you got getters and setters, which are more everyday English. And I think I prefer those more everyday English ones, the getters and the setters. They're just easier. They roll off the tongue a little bit easier versus accessors and mutators. That's really kind of hard to say. You'll hear me say getters or setters. I'll probably interchangeably sometimes refer to the others just from I will like to make sure you're aware that those are the terms as well, and you'll need to know those for the exam as well. So make sure you understand that you need to be able to go between both sets. All right, so attributes of a die. We've got the methods here. If we look into here, we've got 3 methods, really: the constructor method, the roll method, and the get face method. But we really would say we have 2 methods here, because the constructor, while it's a method, it's also the constructor. And so we'd say we really have 2 methods in this class. So that's the roll and the get face. In the class diagram, the plus and minus, again, those are symbolizing the private or public. So this is a private attribute. Most of our attributes are going to be private because we don't want them available for change outside of our class. We want to only be able to change them inside the class with a setter method. So that's what the plus and minus are. Notice how we refer to the roll method. It refers to face, yet that variable is not declared in the method. Why does this work? Because we're working with an object, this particular object. Notice also we're not working with static objects anymore because we're working with non-static, as we call them now, because we're working with an object. So we're going to need an object to call that method. That's what the difference between if you do public static void main, you don't need a main object to work with it and call it. You just call the main, and Java just calls the main because it's a static type of method. For a non-static method, you need an object in order to call that method. So you can't just say roll or die.roll, capital D die.roll. You need to have a die object that you've created like die1.roll. So that's what that difference between the static, non-static means. If it's non-static, which is it is in this case, you need an object in order to call it. So you definitely want to make that distinction and have that understanding of the difference between static and non-static, and that is the difference. We'll go into that in a couple during the next couple of weeks as well, and give you some good examples of that, hopefully. Number 4 here, let's say we're in another class with a main method and we want to declare a die object named Lucky. What would that statement look like? So that statement is going to look like something like this over here. We go die Lucky equals new die. So that's what we would wind up doing, is we need that new, just like we did when we were doing arrays, we need to create or allocate in memory space for this new object of the type die. All right. Moving on to here, we've got what would a statement look like to instantiate the die object. So again, you're here die my die equals new die. So that's instantiating the object. Creating an actual object is that new needs to be in there. You can always just do die my die semicolon, and that will start, that's the initialization of the object, but it's not an instantiation, which is actually creating the memory and allocating the memory space for it. That instantiation happens when you do the word new inside of an object. So number 6 here, when we instantiate an object, we're actually calling a constructor. So that calls that constructor object here. This method has no return types and the same name as the class itself. So what does the die constructor do? It creates a new die and rolls it, and then puts that value into the face value. That's what it will do. So what's wrong with the following fragment of code here? Int value equals die.getFace. Again, this is being called in a static way because we are calling it without having an object created here. So that's the issue there. In order to do that, we would need to say my die over here. We'd have to have that my die that we created earlier. We'd have to say my die.getFace. So that's how we would call it. You can't say the class name.getFace because this is a non-static method. And we've decided to add a method to the die class that will allow us to change the face value directly. What's wrong with the following implementation of that? If we do this one here, we've got this public static void set face int new face, face equals new face. We're just trying to set this face value to that. So the issue we'd have here is it's static and it can't be called against an object here. So we would need to be public void set face int new face, this dot face equals new face. So that would be how we would have to set this up if we wanted to have a set face or be able to load the dice, which we did for the Chuck-a-Lock exercise in the PA midterm, because we wanted to be sure that we had particular sets of die that we were able to work with and test with. And so we created a set face, which is basically setting the die to a particular face value. All right. Similarly over here, this UML allows us to have that graphical representation of the object independent of any programming language. So this is a nice tool as well. You'll see UML diagrams used pretty extensively inside of some object-oriented design tools, and so that you'll be able to create classes without having to actually write code. You can make drawings on a whiteboard and kind of brainstorm how your class is going to work before you actually go code the class. And this is something that comes in real handy as you're going into software architecture in something like, I think 320 is going to be the class that talks a lot around that, and the idea of interrelated objects, and also how a UML diagram works in concert with other diagramming tools and things to allow you to actually build code from a UML diagram. All right, so we've got this circle object here. We've got a radius for that circle, and then we've got several different items here. And this is one that we like to use because you've already been working with the circle object in previous labs and other portions of the course. And so this one, again, should be a familiar one. We're only going to have one simple attribute for it. It's going to have a radius. We're not dealing with any others because we don't need to, because we can calculate the other things like circumference from the radius. So those are the things that we have an economy of design. And that's what you want to go for, is you want to have your class described using only the things that you fundamentally need to know about the class. There are other things that are going to be true about the particular object, but maybe we don't care about those things right now, or we can kind of disregard those things because they don't have meaning with what we're doing. The circle could be have a color object too, but we don't care whether the circle is red, orange, blue, or green. To find the area of the circle, that doesn't matter. That might be an attribute of the circle that it's a particular color, but we don't really care about that particular attribute because we're not doing anything with it in this case. If you were in a game and you were trying to do things with different colored circle objects, maybe you'd care about that, and maybe you'd add that into the code here because you were trying to do something else with those objects. All right. So with this circle object here, let's look at the attributes and methods of the circle. Again, it's just the radius is the attribute, and the methods are the constructor for the circle. We've got the area, circumference, the getter is the get radius, and the setter is the set radius. So all of those methods are public, and then the radius method is private. And again, this attributes are typically private, and your methods are mostly public in a lot of cases. How would you declare a variable named unit that is a circle object? So you'd have circle unit equals new circle sub 1, and we're going to send it a 1 for the radius as we pass in a value into that, because we need to set a value into that radius, this double radius here. So, all right. Draw the contents of memory at the end of your main method here. So this is what the main method would look like, circ. Over here, if we create this object over here, then create a circle object in a main method here, we would have this circ, and this is the circ. It's going to be an object, so it's going to have an arrow type here, and it's going to point to this radius 2.0, because that's what we declared it in this particular statement here. So make sure you understand how to read that and see that. And then there's some code over here that you can go to take a look at this circle object over here. All right. It's the object-oriented pieces. The other piece that we have in here is some JUnit testing. I've given you two examples here. Another example here. This has a complete video walkthrough for how to set this up inside of JGrasp, and then there's a setup for coverage testing inside of Eclipse as well. So you can take a look at that if you're still having problems with setup of your Eclipse or your JGrasp for testing. I'm going to go ahead and get into some of the other pieces today so that we can get into the homework 9 setup pieces. So I'm going to go ahead and jump into that now. I'm going to go ahead and open up Eclipse here. Let's go ahead and save this die class, and then I'll close this out. And then I'm going to create a homework 9 here folder. All right, I'm going to use this Eclipse CS149 in class 1, launch this. And I think I figured out where I was going wrong the other day with the Lab 17. So if I come into here and I now come into here, Eclipse preferences on the Mac is what I was looking for. So for all of those things that I was running into issues with the other day, Eclipse preferences was what I was looking for. I wanted the check style here, and I needed to define a new check style item here. So here's how you would finish out the setup for the check style piece. I'll show you this real quick in Lab 17. Let's go into that. Let me close this down for a second. Move the whole thing out. Let's go into Lab 17 and let's finish out that Eclipse setup. So if I'm in here and I come into this item here, I want to come into Eclipse preferences, and I want to, let's go ahead and make sure we've got the general editor, text editor piece set up. So I've got 3 tabs. I've got spaces for tabs here. I've got this print margin set at 80. I've got show line numbers, show cursor position, all those things set. I think that's the main ones. The 3 is the main one that we're wanting for this semester. Apply and close. Then we can come up back up here to Eclipse preferences, and let's go into here and look at the check style piece over here. Now that we installed check style, we've got the check style here, and we've got this item here as CS149 overall. This configuration, we would have needed to come into here and hit new, and we would want to say external configuration file. And then we would have added the location of that being the location of our actual Eclipse file here. So let's go properties here. This would have said CS149 external configuration file. Then we would have browsed for our CS149.xml file. And that would be allowing us to set up that CS149 type for Eclipse. Let's go ahead and do that. And that the other thing we wanted to do was set up this formatter. So again, not window preferences, but over here in Eclipse preferences, and then Java code style formatter. And so I've created a formatter here. So this is the Eclipse built-in formatter that we've got right now. We want to use an import of our CS149 formatter. So I've created this CS149 formatter.xml file. I'll right click on this, download the file into our CS149 in class folder or the desktop. Then you can go ahead and do this, and then you can say import, and you can pull in that file. I'm going to go ahead and do that. I've already got this CS149 formatter, and I will use this, and I will apply this one as the one I want to use as my specific one for this profile. And I want to use this for this project, and the project specific settings will allow me to set this item here for this. If I go into properties here of the project, then I'm going to go into the Java code style and the formatter, and I want to use the CS149 formatter here. Then when I come into the default package here, I'll come into here. Let's go ahead and delete these 2 items here. And then I can say Control Shift F, Shift Command F in the Mac. It'll be same for Control Shift F, I think, for Windows. Then it'll format your code the right way into the 3 space kind of formatting that we want here. So this is the finalized finish for this piece here with the Lab 17. So if you were having problems with that, getting to that, I was having problems, as you saw the other day. So Eclipse preferences is where we wanted to go for that, and we needed to go to get that. For some reason, it was not showing me that. I think I was too deep in the weeds, and I kept going to file preferences and properties, and that's only showing for the particular project. We want to go for the entire Eclipse IDE, and that's Eclipse preferences on the Mac and Windows preferences on the on Windows or Linux. So window preferences. So under Windows, it'd go window preferences in there to get to that particular piece for your style guide and check style and the formatter piece. So you should be able to go through this Eclipse config video though, and that will have all of that in there if you need to configure your own Eclipse. All right. So let's go ahead and let's get into the next piece here, which is to set up a new project for homework 9. Java project. I'm going to call this work 9. 9 3-4. Yeah, let's go 9_3-4 because this will be 3 and 4. I'll set up the 3 and 4 first, and then I'll do the other one. Remember, we want to use the project folder as the root folder for our classes. I'm going to go ahead and hit next, and then I'll hit finish. So we've got this project set up here. I'm going to go ahead and close this out, come into here, and we'll go into this project, and we're going to right click in here, new class. And let's go ahead and create our class file here for this one. This one in chapter 9, homework 9, number 3 is big fractions. So we're going to want to create a big fractions.java file or a class called big fractions. I'm going to go ahead and create a main in here too, just to have that. I'll generate my comments just so I don't have to do anything else. I want to leave it in the default package, even though it's discouraged by this IDE. We want to do that. Let's go ahead and do that. So big fractions.java is created here for me. I'm going to go ahead and fill out some of the pieces for my item here. Big fractions. Testing for big integer type examples. All right, I'll leave the author name as my EID because I don't like that. That works fine for me. As 4-7-21. I have followed the honor code. All right, let's go ahead and do that. And then we'll get started in here. We're going to go main here and at param args not used. And then we put in any main section we want in there to test this big fractions. Okay, so in here, we're going to create a new class named big fractions that contains the method reduce. So let's go ahead and grab this and place it into here. And then let's get the Java doc written for this. Nice thing is Eclipse is going to help build that for us. Reduce will return a string for the fraction reduction. All right. And then we're going to say numerator of the fraction, denominator of the fraction, and return string reduced fraction string. All right. So that's what this method is going to do for us. The other thing we're going to need to do is we're going to need to import the big integer type, I think, because it's not liking this over here. Yes, because it doesn't have that type. So we're going to have to actually do an import, I believe, here. Import math dot. And it may be java.util.math. Not big integer. Let's see. I want to find where that is. Where is the import? Let me go find that. We're here. Where's the big integer class? There we go. There we go. So import java.math.biginteger. That's the one we want to do from this documentation here. And you can go through the documentation and you can kind of see how to build these integers. So we're going to need to work with these different classes here, or these different constants here that we have that will help us along the way. We've got this idea of 1s, 10, 2, and 0. So hopefully you're understanding what this whole thing is talking about when we say big integer. So we're working with these numbers that are 4 septillion over 8 septillion, okay? That's what we're reducing, is this giant number over another giant number. So 4 septillion over 8 septillion really reduces to 1/2, because it's going to be 1 septillion over 2 septillion as it reduces, or 1 over 2, honestly, as we reduce it. So what we're going to try and do is create this big integer reduction that is going to take these mixed fractions and reduce them down. So if we've got 14/4, we need to take this 14 over 4 and find out that it is 3 and 1/2, and that's 1/2. That's how we're going to represent that. So we need to be able to do that and to return that kind of value. So in order to do that, we're going to want to return some things. But in this case, what we're going to do is we're just going to return, create a return string, and we're actually going to say error right now because we want to have an error show up, because that's what we want to return. Out the gate. That's the stub that we're going to create for this, because we don't have anything we want to return yet. So if we do 1 divided by 0, we would want that to return this error case here. So note down here, it says your solution must not use loops. So Autolab is going to score you down and give you 0 points if you try to use a loop here. So you're going to have to work through this in other ways to find this greatest common divisor here. So, and notice here, there's a method for this greatest common divisor here inside of the big integer documentation here. So if we go to the big integer documentation, we can look down here and there's a GCD, so of the big integer value. Returns a big integer whose value is the greatest common divisor of ABS this and ABS value. So this value and that value. So if we go take 2 big integers and we run this GCD against that, so we can find out what the greatest common divisor is between those 2 values. So that's what we want to do, is use that greatest common divisor in part of our solution here. So make sure you're understanding that that is another tip of the day for what you want to be doing to get these pieces out for the big fraction pieces here. All right, so let's go ahead and do this. We've got this set up where we've got enough of this so that we can do some testing. Let's go ahead and create a test in here inside of Eclipse. So let's go ahead in here and we'll go right click, new JUnit test case. And I'm going to set up the test case for this. I'm going to set it up as a JUnit Jupyter test here. And I'm going to say big fraction test. That's fine. We're going to generate our comments, and we're going to class under test is big fractions. That's great. It filled in that blank for us. We're going to hit next. And then we want to test this reduce method here is the method we want to test. And we'll create a task for generated test methods and final method stubs, sure. And we'll click finish. The last thing that this asks us to do is add JUnit 5 library to the build path so that we can run JUnit inside of Eclipse. we want to do that. And let's go ahead and hit OK. That, as you see over here, adds JUnit to the package of the Java package that we have in Eclipse. That allows us to run tests in here. So now we've got these pieces here. I'm going to go ahead and change this up because we don't want, per our style, we don't want this to be static type call. We want this to be org.junit.assert and it's assert is the one we want to do. We don't want to do the asterisk one, and we want to do org.junit.test. So those are the two imports we're going to do instead of the way it was being done. All right, and then we're going to go over to here and we're going to get rid of this java.comment. This is just like we did before with all of our JUnit tests. So we've got big fractions test. Let's just copy this over here. .4, and this is over here at version 4-7-21. I have followed the honor code. All right, and we're going to do this as public class here as well. And then we want a test method here for test reduce, and we're going to create a test in here. Let's do testing a improper fraction, actually. Let's call that this test. And what an improper fraction is we'd be testing for 3 1/2. So this idea of the improper fraction is 14/4, where it doesn't reduce down just into a fraction, but it's one of these, a number and parts of a number left over. So that's the improper fraction. So let's do that. Let's go string expected equals 3 1/2. That's the one that we had from before, this 14/4. So we're going to do this testing by going big integer numerator equals big integer dot 10 dot add big integer So in order to create the number 14 in big integer, this is how we have to do it. We have to do a dot add of 2 and then a dot add of 2 to 10, because over here we've only got constants in the big integer for, what are they? 1, 10, 2, and 0. So those are the only values that we have that we can work with. So we need to build any other numbers. So this is going to be 14. So basically this, in order to build 14, we have to take 10, add 2, and then add 2 to that. So that's adding 4 basically to 10. So 14. So that's what we're doing over here. We'll also need to do an import of the big integer in here, I think, because it's not. Oh, there, it already just grabbed that big integer import for us actually in this one. So let's see. Yes, okay. So we need that. Let's go ahead and go into here, and we've got this next one that we want to do is the denominator. I'm just going to copy this one over here. So we've got the denominator here, which we want big integer dot 2 dot add and big integers dot 2. So we're going to add 2 and 2. Basically the starting value 14/4. So we're going to work with that, and then we're going to come into here and we're going to make an assertion here. The assertion we want to make here is an assert true of improper fraction for 14/4. And we're going to say expected dot equals. So this expected It's a string, so we need to do a dot equals. So 3 1/2 dot equals big fractions dot reduce subnumerator comma denominator. So that's going to be our one test in here. You'll need to do some other tests for other items here. I think we've got a good start for you inside of here. This 14/4 was an improper fraction. A proper fraction would be this one here. We would want to go into this one. We might want to have an even one here. And then we might want to do an error here. So let's go ahead and I'll set up the test for a divide by 0 one too. So let's do this. And we've got this guy that we want to test to. So test divide by 0. And inside of here, we're going to set up a test case here where we've got a string expected equals error. And then we've got a big integer dot numerator equals, over here we've got 1. And so we could say big dot 1. And then we've got a big integer dot denom, and that equals big integer dot 0. And it's going to build that case for us there. All right. There we go. All right. And then over here, we're going to have an assert true. That we've got this idea of a 0 divide by 0 case, and we want to say expected dot equals big fractions dot reduce sub numer comma denom. All right. Not number, but numerator as a numerator. And we want to reduce that. Yes, okay. And that's dot equals, okay. All right, so we're now compiling this out. Now, if we were to run this test, we can come up here and this will run the test. It's going to show us that we're failing one of the tests here. Which test are we failing? We're probably failing the improper fraction test because we're actually probably passing the other test just fine. So that is how we would go ahead and run that. You hit the little play button here, and that will actually execute your tests. So now you'd want to keep writing more tests and actually finish out the tests. These would be the ones that you would want to test. These other 2 tests you're going to need to build yourself in here. You should build those. They're pretty simple to build. After you have this example here, you can follow, take that example and build the other one in there for the big integers. Then the big fraction, you're going to have to write out the rest of the code in here to finish up this piece. And that's the piece you would want to finish out for the actual big fractions portion. All right. So I'm going to go ahead and now come out of here and go into JGrasp to do 9.1 and 9.2, because I want to do that in there just to show you how to do that there so that we've got examples in both Eclipse, which I just showed you, and then JGrasp as well. All right, let's go ahead and exit out of Eclipse. And let's go into JGrasp. All right. So I've got this homework 9 here folder I'm going to use in here. This will be just for 9.1 and 9.2. So let's go into here and let's go File, New, Java. And we're going to create 9.1, which is this batarray.java. So I can actually just either download this and put this into here as batarray1.java. And I'm going to create these 3 different methods here. I'm going to create this common end, the mid 3, and the static. Let's go ahead and finish out the stubs for this. Return 0 for this guy. We'll do a return of mid 3. It needs an integer array. Let's go int array. My ints equals 0, 1, 2, 3. Let's do that. And let's do that. Actually, let's do 4, 5, 6 here because we know we're going to want to probably have that as a case. Here, let's go ahead and do that. And then let's do return my ints. All right. Come into here and let's go ahead and stub this one out. And we want a Boolean here, return false. All right. So we've got this all stubbed out here. And working from a compiling standpoint, we can check style this and make sure we've got everything. We are missing our Java doc pieces here. And I want to go 4.7.21. The JMU honor code. All right. And now we've got our Java doc comments all filled out. All right. Let's go into here. And from here, I'm going to now go into 9.2 and create some batarray1 test. So I want to come into here and I want to create the JUnit test file with this rainbow document here. And then I can go ahead and get rid of these 2 assertion items here, this, and just leave JUnit assert and JUnit test as the 2 imports I want to do. Then over here, I want to come into here and just set up my actual tests. So let's go ahead and set up a test here. This will be test test common end, test common end, and I want to test the common end method. So inside of there, probably want to do some items here. Let's go look at test common end. So common end over here will allow us to look at this. If I just go into here and I go, let's go ahead and return false. We'll go. I want to set up some tests here for this kind of scenarios. We can use these tests as the tests we use for our unit testing here. This will work out pretty well. Let's go case 1 and let's set up a case 1. And we can even just copy this out here. The one thing you'll want to do is if you do copy out stuff from there, you'll want to make sure you handle these funny arrows and stuff like that. So let's not do that. Let's just copy the heart of it, not the 3, 3, 7, 3, true. All right, so that's what we're expected. All right. So let's go ahead and build this case. So we're going to want to pass it an array of 1, 2, 3, and 7, 3 as our two arrays that we're passing to common end. So we want to pass our first array. What are we calling this? A and B. So we can create an int array A equals 1, 2, 3. We can create an int array B. Array B equals 7, 3. And then when we go common end, we expect this to be true. So we would want to go assert true, common, let's call this 1, 2, 3, 7, 3. Man, I cannot type today. All right, there we go. And then we want to do this as common end, actually bat array 1 dot common end of A comma B. And we're going to send our two arrays into there. And that should give us a good assertion. Let's go ahead and compile this. And we'll run this. And right now we're having a fail here because this is coming out false because we just said everything was false in this bat array 1. So we want, if we change this to true, we would actually pass this test, but obviously this is not anything that's correct here. So let's save this guy. Let's recompile this guy. And then let's come in here and let's compile this and run this. And now this is passing, even though this is not correct, but we know why it's not, it's passing and it's not correct. So you'd want to finish out this common end here, then you're going to want to finish out some tests here. Really, you should finish out copying the other tests here with 1, 2, 7, 3, 2, 1, 2, 3, 7, 3, 2, 1, 2, 3, 1, 3, and you can do a couple of different ones in the common end, add in several more tests in there. Then you're going to want to set up the other tests that you have in here. So another test for, we're going to want to come into here and do a second test for the second method mid 3. So we're going to want to add test. So yeah, you could always create a new int array set. You would not create a new A and B. You'd probably want to go C and D inside of there, or A1, A2. So int array A1 equals 1, 2, 3, or you could keep passing. So because if you look over here inside of this, we're actually passing that same A into there. It's the B that's the different one. So we would actually be able to reuse A, and let's say B2, let's call it, equals, and we're going to call it 7, 3, 2. So this is what I would wind up doing if I were trying to do this testing. I would overload that and reuse that A and just set up the new one here. And I would set my second test in here. Let's go here, second test, case 2. And this is for 1, 2, 3, and 7, 3, 2. So I would do this, and then I would copy this guy into here and do these as this. And then I would comment end of A comma B2 here, so that I could actually do that and reuse the A, because the A is the same A there. So you wouldn't be able to reuse those because you've already declared it once with that. You wouldn't be able to reassign those. So I would just create another array instead of trying to reuse that stuff that is not going to reuse well. So this one again over here is 1, 2, 3. So you're going to reuse that A, and then we can create a third case here. So case 3 is 1, 2, 3, and 1 over here. So let's slap that in there, and 1 in here. And this is going to go into array B3 equals 1. And we're going to go B3 here, and we're going to assert, actually this one would have been an assert false. And then this is an assert true again. And then we've got our last one over here. Case 4 would be an assert false again. So that's pretty much that one there for you. And you can create some other tests. That would be the best thing to do, is make sure you create some other tests if you need to, because you can see over here we have this other test idea. And so these are not complete tests, but these are a good start for your test. And so using the tests that are there in Coding Bat is a great idea. Go ahead and start using those, and then create a couple more tests in there as well. And again, mid 3 would be setting up that second test over here, and then just setting up a test for mid 3. So hopefully this gives you a good start to this. And if you have any questions, TA hours will be this evening, and I can be available via the Teams chat kind of thing. So if you're having some problems, try and get to those earlier. We'll probably be busier in the mid to late evening kind of hours tonight, and often am in general in the late evening hours, or kind of I'm occupied usually between the hours of like 5 and 9. I might check email around 10:30, but you probably won't get me until the next morning. So if you do put something in, though, feel free to put something in, and I may get to it in the morning and answer you early in the morning. But otherwise, you've got TA hours this evening, and then TA hours tomorrow evening as well to assist you with that. Plus, again, during the day, you can feel free to Microsoft Teams chat and put a question in there, and I'll be trying to answer that. All right, class is over, so get on to your next class if you need to. Otherwise, I'll be around for office hours as well. I'm going to go ahead and close this call and then open up the office hours call, though.